All right, so we're going to go ahead and work on cumulative review number 1. So, a plane landing on an aircraft has just 350 meters to stop. If its initial speed is 82 meters per second, what is the acceleration of the plane during landing? Okay, so the plane is going to land on an aircraft carrier. Okay, an aircraft carrier is a big boat. Okay, in the water, so it wouldn't be a plane quite like this, but that's okay. So here's my big boat that's in the water, all right? And here comes the plane. It needs to land here. It's got 350 meters to do so. All right, so we're talking about the landing when it's on the quote-unquote ground, on the surface of this boat, okay? So that means it's not in free fall, nor was it in free fall when it was in the air, because it wasn't falling, it was flying. So I'm going to go back to chapter 2 to write down the list of givens. So we've got delta x, delta t, vi, vf, and a. Again, it's not falling, so acceleration is not negative 9.81. I know we're in that chapter, but we're going back and reviewing here, and this is from chapter 2, where we have objects that are moving in a straight line, okay, in the x direction. So 350 meters, that is delta x. That's how much room we have. If we don't stop in 350 meters, we're going to fall off into the water, okay? If its initial speed is 82 meters per second, okay, so that's my initial velocity, 82 meters per second. What is the acceleration? So I'm looking for the acceleration, A. Okay, it looks like we're missing some information here, but there's some information that's in the form of a word. A plane landing on an aircraft carrier has just 350 meters to stop. So if I'm going to come to a stop, I'm going to be going 0 at the end. So I'm going to choose the equation that does not have delta t. So vf squared equals vi squared plus 2a delta x. Vf is 0, so 0 squared equals 82 squared plus 2a times 350. 0 squared is 0, 82 squared is 6,724 plus 2a times 350. Need to solve for a. These are not like terms. This has an a, this does not. So I'm going to move it over. So I'm going to get negative 6,724 equals, and then I can combine these. I can multiply in any order, okay? The commutative property of multiplication. So I'm going to multiply 2 times 350, and I'm going to get 700, and then I still have to multiply by a, but I don't know what a is, so I'm just going to write it there. Now we need to divide both sides by 700. And we get that the acceleration of the plane needs to be negative 9.61 meters per second squared. Okay? It's negative because we had a positive velocity, so it's moving to the right. So if I want to slow down, I need the acceleration to be in the opposite direction, which is the negative direction, to the left. All right, number 2, a car with an initial speed of 28 meters per second to the right accelerates at a uniform rate of 1.8 meters per second to the left. What's the final speed of the car after 2.5 seconds? So we've got a car moving along, okay? Again, not falling, so I'm just going to use my chapter 2 variables. So we've got delta x, delta t, vi, vf, and a. A car with an initial speed of 28 meters per second to the right, so it's positive, accelerates at a uniform rate of negative 1.8 meters per second squared to the left. So they're opposite directions, so we should anticipate that this object will be slowing down. What is the final speed after 2.5 seconds? We don't know delta x, so we'll choose the equation that does not have a delta x. So Vf equals Vi plus A delta t. VF equals 28 plus negative 1.8 times 2.5. So the final velocity is 23.5 meters per second. It did slow down. Okay.